Today's visualization is prime number DNA, a double helix shaped entirely by prime number frequencies. It begins with a simple helical path formed by cos of t and a steady rise in y, creating the familiar twisting motion seen in real DNA strands. The x-axis is sculpted with high-frequency waves using primes like 31, 71, 127, and 179, adding fine ridges, depth, and texture. Along the y-axis, sine waves based on the first primes 2, 3, 5, 7, 11, and 13 introduce layered vertical motion. Because primes rarely align, their oscillations blend into patterns that feel naturally complex and never perfectly repeat. A soft pulse gently expands and contracts the radius, giving the strand a subtle sense of life and movement. This approach represents one of the most accurate mathematical ways to mimic a DNA-like helical structure using pure wave interactions. Final scaling keeps the form centered and continuous as it rises. Subscribe for more CM2A explorations.